Hello and welcome to Chapter 2. Today we'll be talking about Module 4, Systems and Matter. But before we get started on that, I'd like for you to carefully read this story about Mono Lake and consider how can a single change made to an ecosystem have a ripple effect and cause more changes. This is a concept that we will be talking about throughout the year in environmental science. All right, moving on to Module 4. The first part we'll be talking about is atoms, molecules, and matter, the importance of water, and conservation of matter. Before we get started, I'd like for you to take these parts of an atom and make this Venn diagram. So the parts of an atom are electrons, neutrons, and protons. Pause the video and fill out this Venn diagram, please, in your notes. Okay, hopefully your Venn diagram looks something like this. So electrons have a negative electrical charge. Neutrons have no electrical charge. Protons have a positive electrical charge. Protons and neutrons have the same mass, which is much more than electrons. Electrons have such small mass that it's almost negligible. Electrons and protons both have a charge, and electrons and neutrons do not determine an element's identity. If you have anything on your chart that I don't have on mine, please bring that information to class so that we can discuss it. If you are missing anything on your chart, fill it in now. All right, another point I'd like to make is that mass and weight, although they're used interchangeably quite a bit, they are slightly different. Weight includes a gravitational pull. So an example of that, if you look at this chart, if a person weighs 150 pounds on Earth, then on Mercury or Mars, they would only weigh 57 pounds. But if they went to Jupiter, they would weigh 351 pounds. So you can see why weight and mass are used interchangeably sometimes, since we're all on Earth. However, this is, it's important to understand that distinction. All right, so when we're talking about elements, you want to think periodic table. So look at this, at the periodic table in the back of your book. It's on the back cover here. It looks just like the one that you use in chemistry and probably looked at a bit in other science classes as well. Let's look at one element. Let's look at nitrogen. This is one square that talks about nitrogen. In the periodic table at the back of your book, it also has the electron configuration, which is a 1s2, 2s2, 2p. We will not be using this, but just as a reminder of what that is. Nitrogen has an atomic number of 7, and that is the number of protons. It has a mass number of 14.007, often it'll just say 14. That is the mass number, which is the protons plus neutrons. Another important thing to remember is that in a neutral atom, protons will always equal electrons. You can remember that if it's neutral, it would have to have the same number of positive charge as negative. Please take a moment to look at the periodic table, draw this chart with all of these elements, and make sure that you have an example for each. So these elements here, atomic number and number of protons with an example. Take a moment to pause the video and fill that in, please. Okay, hopefully your chart looks something like this. So notice the atomic number and the number of protons are the same all the way down. Some examples, you can have different examples, of course, but notice that these that have two different elements attached to each other are called compounds. So 1, 2, 3, 4 of these are called compounds. These two here are diatomic, and that means that they can be added, they can be attached to something else. Like here, oxygen is attached to hydrogen and there's only one of them. But they can't ever stand alone. So you'll never see oxygen or nitrogen all by itself. So they're called diatomic. Okay, another thing we need to talk about is isotopes. Isotopes means that there's a different number of neutrons. And the way that you would write that is if carbon had 13 neutrons, you would write carbon 13. Or to abbreviate it, you would write 13C. That would be the isotopes, and we'll be talking about this in class as well. Radioactivity, when we talk about radioactivity, it's usually so that we can talk about half-life, which is usually so that we can talk about carbon dating. And carbon dating is how we can know the age of rocks or elements in our atmosphere. Recognize that when radioactive elements. When radioactive decay changes the radioactive element, it changes the radioactive element into a different element. And when that happens, a lot of energy is emitted. So nuclear power plants can use this to create electricity. Here's a question for you. What is the difference between an element that has a half-life measured in years and an element that has a half-life measured in days? The answer is opposite to what many students think. An element with a half-life measured in years will stay radioactive longer because it takes years rather than days to lose half of its radioactivity. All right, when we talk about bonding, it's just important that you know these three different bonds. Know the differences between the three and how they are similar: covalent, ionic, and hydrogen. All right, now let's talk about the properties of water. Please write this chart in your notes. We're going to go over 5 different properties of water and their function in the environment. Go ahead and make a chart and you can fill it in as I go through on the notes, as I talk about them. The first one we're going to talk about is surface tension. So we'll write surface tension here. So surface tension is important. Perhaps you remember doing this experiment. So excuse me while I turn the camera. Remember doing this experiment where drops of water on a penny. Sorry, it's hard to hold still. There are 77 drops of water on this penny. And they're held together. You can see that it kind of creates an orb. And they are held together by the surface tension of the water. So that is surface tension. It also allows this little guy to be able to walk on the water because of the surface tension. And there is surface tension because water molecules are attracted to each other. Another one we'll talk about is capillary action. Right, capillary action here. And consider trees, leaves at the very top of a tall tree. So trees have these cool little pipes called xylem, and somehow the water is pulled from the roots way up to the leaves at the very, very top of the tree, and that is by capillary action. So the water sticks to each other. It's very similar to surface tension. Sticks to each other and pulls up through those pipes. Okay, I'm not going to continue writing on the chart just for time, but hopefully you can continue that. Number 3, we're going to talk about boiling and freezing. So water has a high boiling and melting points, and this is what allows it to remain liquid water on Earth. Water expands as it freezes. So when water expands, it gets larger and it starts to float. So if water floats when it's frozen, consider that icebergs are above the water, not from the bottom up, and also lakes. Lakes freeze on the very top, and animals get to continue to live underneath in the wintertime. It is also a very good solvent. Water is called the universal solvent because it can dissolve nutrients and bring those nutrients to biological systems and living things. So your chart should look like this one. If you're missing anything, please fill it in now. All right, when we talk about pH, a higher pH equals more basic. So often students will get this backwards and they'll think that really basic would be really small and that really acidic would be really large, but they are the opposite. So the higher the pH, the more basic. A few of the things that we'll be talking about are nitric acid and sulfuric acid, and that is a specific kind of acid deposition, an example of which would be acid rain. So let's look at this chart together, and I'd like for you to answer these 5 questions in your notes, and then we will go over them in class. So the pH tolerance on aquatic life. Look at it very carefully and answer these 5 questions, and I will check these questions for you in your notes. I'll pause for just a moment for you to write them down. Okay. All right, so now we're going to talk about chemical reactions, everybody's favorite part of chemistry. And again, I'd like for you to write down these chemical equations, filling in the blanks to make them balanced equations. And then bring these answers to class, and we will go over them. Okay, so recognize that the law of conservation of matter is why balancing equations work. So organic versus inorganic molecules. An organic molecule will have a carbon-carbon or carbon-hydrogen attached to each other. That's how you can know that it is organic. There are 4 types of organic compounds. You've heard these before: carbohydrates, proteins, nucleic acids, and lipids. They all have very different function and structure. Carbohydrates are composed of chains made of carbon, hydrogen, and oxygen. Proteins are composed of amino acid chains. Nucleic acids are double helix structure composed of nucleic acids. And lipids contain fatty acid chains attached to a glycerol group. So again, this should be review for you. And finally, this cell. So we will be talking about single-celled organisms as well as multi-celled organisms. So I hope you enjoyed this module. It is very much review, but some of the things that you haven't probably thought about in quite a while. Please bring the questions and the chemical reactions to class, and we will go over them in class.